All right, let's continue with number 53. We're looking for the derivative of x squared times e to the x minus 2x e to the x plus 2e to the x. And when we do this, you should note that you have a couple of product rules in there. X squared e to the x is a product, minus 2x e to the x is a product. Only the final term, 2e to the x, is a constant multiple rule. So we're going to have to do this carefully, especially when you have a minus sign, minus a product there. You're going to have to take that with a little caution. Okay, so with the first one, we're looking for the derivative of x squared e to the x. So it's 1. The first function is x squared, second function is e to the x. 1 d2. And since the derivative of e to the x is just e to the x, 1 d2 comes out to be x squared e to the x, plus 2 d1. In this case, 2 is e to the x. The derivative of the first term is 2x, so we're going to have plus 2x e to the x. And now we found the derivative of x squared e to the x. Now we want to minus or subtract from that the derivative of 2x e to the x. Alright, so again we have two functions. The first function is 2x, second function is e to the x. And I'm going to put this in parentheses since that minus has got to apply to everything here. And 1 d2 is still just going to be 2x e to the x plus 2, which is e to the x, d1. The derivative of 2x is just 2. So that left me with minus the quantity 2x e to the x plus 2e to the x. And so that is the derivative of the second part. The derivative of the third part, 2e to the x, is just going to be 2e to the x by the constant multiple rule, since the derivative of e to the x is just e to the x. Alright, we can simplify a little, and since we only have one x squared e to the x term, we can write it first. Then we have 2x e to the x minus 2x e to the x. So those two will zero out. And then we have minus 2e to the x plus 2e to the x. So those two will zero out. Because when we distribute the negative 1 on the outside of the parentheses to the positive 2e to the x, that becomes negative 2e to the x. Plus 2e to the x gives us a 0. So the final answer to that one is just x squared e to the x. And so that's it for problem 53. Alright, we'll go on to problem number 55. And so we have the product e to the negative x times the natural log of x. And we're going to need a product rule here. So it's 1. d2, the derivative of natural log of x is 1 over x, plus 2 natural log of x. d1, the derivative of e to the negative x is e to the negative x times the derivative of negative x, which is negative 1. So that comes out to be negative e to the negative x. And that's not subtraction there. It's natural log of x times negative e to the negative x, which when we rewrite this, we would get, and moving the e to the negative x in front of the natural log of x, we'd get e to the negative x over x minus e to the negative x times ln x. And we do have an e to the negative x that we can factor out. And so we would get e to the negative x times 1 over x minus natural log of x. I could multiply the natural log of x by x over x and combine them together. Let me just go ahead and do that. And again, why would I want to do that? Well, it's easier for me to see where the derivative is going to be 0. It'll be 0 whenever 1 minus x times ln x is equal to 0, and who knows what that is. And it will be undefined when x is equal to 0. Alright, so that's it for number 55. And I'm not sure which of those forms the book would have left it in. To go on to number 57. We're looking for the derivative of e to the x times the sum sine x plus cosine x. We do have a product rule, so that would be 1, which is e to the x times the derivative of sine x plus cosine x, and that comes out to be cosine x minus sine x. So it's 1 d2 plus 2, and d1, the derivative of e to the x is e to the x, so we ended up with e to the x cosine x minus sine x plus e to the x sine x plus cosine x. Factoring out an e to the x, we get cosine x minus sine x plus sine x plus cosine x. And the signs should zero out, and we get 2 cosine x. Or finally, 2e to the x cosine x. And that wraps up 57.